sliding motion. That was at the top of our note sheet from Friday. It's the sliding motion. So, a translation or slide is a transformation that moves all points of a figure the same distance in the same direction. Okay, so we're taking all of our points, we're moving it the same distance, okay, the same amount of space, and in the same direction. Okay, a translation is a function that maps each point to its image along a vector called the translation vector. Okay, so we're going to be looking at different vectors today to move our points. Now, your translation vector, each segment joining a point and its image has the same length as the vector. Okay, so this same length right here will be congruent to that vector there. Okay, so from point A to A prime, those two pieces are congruent. This segment is also parallel to the vector. Okay, so it is also parallel. So you can see those arrows in these two cases. So from point A to its image, A prime, that line created between the 2 points is going to be parallel to that translation vector. Okay, so a translation vector shows length and direction. Okay, so it'll tell you how long it has to be and which direction it is going due to this arrow at the end. Okay, so this one was your vector. Okay, it's saying how long it is, and then this is your direction marker here at the top. Okay, it is named with a symbol and lowercase letter. Okay, I know this one's hard to see. So your vector would be labeled with a lowercase letter. I'll just use V. The symbol above it is this half arrow type symbol. Okay, so that's the symbol for a vector. All right, so just to see what a vector does to a figure, we're going to use the figure in the given translation vector, then draw the translation of the figure along that vector. Okay, so here is vector P. Okay, we want to move each of these points in our original figure along that vector. So from M to M prime, that is the same length as our vector P. So our M prime point should be at the end of that arrow. Okay, that's the same thing for L, O, and N. Okay, so they have to move in that same direction, that same length. Okay, and then we would just have to connect each point. And that would be your image. Okay, not so bad. Any questions so far? All right, so we're going to see component form of a vector. So that's the form we're going to use in order to move our points on the coordinate grid. So a vector in the coordinate plane can be written as with these brackets A, B. Okay, so again, your brackets are these pointed arrow type brackets. That would be your component form. Okay, when you see it in those arrowy brackets there, it is a vector. It's not a point on your graph. Okay, where A represents the horizontal change, Okay, so that's left and right. So A will move your point left or right. And B is the vertical change. Okay, so that will move your point up or down. Okay, so at the right, CD is represented by the ordered pair 2, -4. So this is in component form. This is a vector. This 2 moves it right 2 units. This 4, or this -4, will move it down 4 units. Okay, so our A value here moves it left or right. B moves it up or down. If it is negative, it goes down. If that A value were to be negative, it would go left. Okay, so if this is your pre-image right here, this point, to use your vector, you just have to go right 2 units. And then take that point and go down 4 units to get to your image, which is point D. So again, this vector here, this B value, moves your figure up or down. And if you have an A value here, that moves the figure left or right. Okay, so on the coordinate plane using a vector, okay, if I'm going from point P to point P prime, okay, you're using a vector to move it. So here's your vector, AB. Your original coordinate is XY. A changes your X value. B changes your Y value. Okay, all you have to do to get your new coordinate is add together X and A and add together Y and B. Okay, that would give you your image coordinate. So for P and P prime here, my original is -2, 3. Okay, so I have -2 and 3. So this added 7 and this added 4 here are going to be your vector that you use to change that coordinate. So our vector from P to P prime would be 7, 4. Okay, because I'm adding 7 to our original -2, and I'm adding 4 to our original 3 here. Okay, when I do that, my new point P prime is at 5, 7. Okay, so you're just using your vector to find that new image. Okay, questions before we do an example on the coordinate plane? Okay, so for each of these problems, we're going to graph the figure and its image along the given vector. Okay, so the first thing we want to do is graph this triangle EFG with our given vertices. Okay, so I want you guys to do that now. So graph point E, point F, and point G. If you would like a straight edge, I do have rulers up here as well, if you'd like one. Alright, so your triangles should look similar to mine, should be in that same area. Please make sure you label each point. Okay, label point E, point F, and point G. So I'm going to show you 2 different ways that you can use your vector. Okay, the first way is what we talked about on the bottom, on the front. Okay, so I can take my point E. Okay, point E is at -7, 1. Now our given vector is this 2, 5 right here. Okay, you can see those arrowed brackets. So to change from E to E prime, I need to add 2 onto my x value. So I would have negative 7 plus 2, since that 2 changes your x value. Okay, same thing with negative 1 here. I would add on that b value from my vector, which is 5. Okay, so E prime would be at negative 5, 4. Okay, so that's one way to do this. So I can plot my point E prime. It's at negative 5, positive 4. And I'll label it E prime. Now, another way you could do this, that's what I'm going to do with point F here. Okay, point F is right here. Using my vector, I know my point has to go right 2 units. So I'd go right 2, 1, 2. I'd have a point here then. And I have to go up 5 units. So from that point, I can go up 5. 1, 2, 3, 4, 5. That would be my new point after I move it along that vector. Okay, and that would be F prime. Okay, I'll show you that again with G. So if I start at point G, I have to go right 2 units. So from point G, I'll go right 2, 1, 2. And then I have to go up 5. So 1, 2, 3, 4, 5. So my new point would be right here. And that would be G prime. Okay, and then I would have my image drawn in. And again, just like yesterday, I do want you to write out each of those prime coordinates. Okay, so I already have E prime written out, okay, because I added here. So I also need F prime. Okay, F prime is at negative 2, 1. And G prime is at negative 1, 4. Okay, questions? All right, then do letter B. Okay, so letter B, you have this square with your given vertices along this vector at the end here. For F and G, you're using your vector here. So from your point G, you have to go right 2 units and then up 5 units. I was showing you the 2 different ways that you could do it. So you could do it this way for all your points, or you could do it off of your graph for your points. And yep. I'm showing you the 2 different ways. Just so you know. All right, so looking at letter B, your original vertices, J, K, L, and M are right here, that square. Now this vector, this -3 here, is going to move each of your points left 3 units. Okay, this -4 is going to move each of your points down 4 units. Okay, so left 3 units and then down 4 units. So finding each of my image points, from point J I need to go left 3, so 1, 2, 3, and then down 4 from there, 1, 2, 3, 4. So J prime is going to be at 0, 0. Okay, same thing with point M. Go left 3 and down 4. Okay, and that would be M prime. So M prime is at 2, 2. L, left 3, 1, 2, 3, down 4, 1, 2, 3, 4. So L prime is at 4, 0. And then K, K prime should be at 2, -2. So again, please make sure you're writing out these prime coordinates. If you did not, make sure you do that, please. Make sure yours is similar to mine. So again, that first number, that A value in your vector, moves left and right. The B value, the second number in the vector, moves up and down, just like you would plot a point. Okay, so that first number changes your left and right value from the origin. Your X value in your coordinate point, you move left or right first and then up or down. Okay, same thing in your vector. Okay, questions on letter B? All right, last problem here. In one part of a marching band's performance, a line of trumpet players starts at position 1. Okay, that's right here. Marches to position 2, so over here, and then to position 3. Each unit on the graph represents one step. Describe the translation from position 1 to position 2 in function notation. So if it asks you to do this in function notation, okay, it's talking about the vector that they're using. So you're writing it as A, B in your arrowed brackets. Okay, so if I want the vector from position 1 to position 2, okay, so that's from here to here. So starting at this point, moving to this point. Okay, I'm moving this way. Okay, so I'm moving left. Now if I look down here, each of my units here is going down by 2. So each of these are 2. So this would be 1, 2, 3, 4, 5, 6 to get to that one, right? But if each of these spaces are 2 units, how many is that? 12. So I'm going left 12. Now in my function notation for a vector, your left and right value is A or B. Which one? To move something left or right, should I use A or B? A. So my vector for that movement is going to be -12, 0, because I'm not moving up or down after that. Okay, and that's how you need to write it. Please don't write it as a coordinate point. Okay, so you don't want these curved brackets. It has to be that arrowed bracket there. Make sense? You do have a problem like that on your assignment where you have to figure out what the vector is in function notation. All right, then I do want you to start